Hi, my name is Alexis Taylor, and this is my patent office presentation. What is the Haber-Bosch process? This part of the presentation is going to go over some of the historical background so you can become familiar with what the Haber-Bosch process is and what it does. The Haber-Bosch process is a process in which ammonia is synthesized. It was created by a German Jewish chemist named Fritz Haber, who created this process to create an economically feasible fertilizer. During World War I, nitrate that was being used as fertilizer from Chile was being blocked by British naval blockades. So they couldn't bring any of that nitrate in because it was being blocked by the British naval. He also developed poison gas, which was the first example of chlorine gas during the war as well. Then in 1931, two chemists, Carl Bosch and Frederick Bergens, jointly translated the process on a much larger scale, which granted a Nobel Peace Prize for high pressure studies. So, how does the process work? The ammonia synthesizing process, which is the Haber process, which is the first to use high pressure for chemical reactions. So how it works is nitrogen air directly combines with hydrogen under extremely high pressure and moderately elevated temperatures. A catalyst made of iron enables the reaction to be carried out at a lower temperature that forms ammonia. This ensures that an equilibrium favoring product formation is maintained. The lower the temperature and the higher the pressure used creates a greater ammonia yield in mixture. The process produces 450 million tons of ammonia, which in turn produces ammonium nitrate for fertilizer. The Haber process has led to an abundance in agriculture. So you see that the temperatures are usually between 400 and 450 degrees Celsius for the iron catalyst to be used to make the liquid ammonia. The Le-Chatelier's principle. What is the Le-Chatelier's principle? The Le-Chatelier principle is the description of a chemical equilibrium system when it responds to stress and what the system will do to relieve stress. Examples of stressors to a chemical reaction could be temperature, pressure, and changes to the concentration of either the product or reactant. When a forward reaction is favorable to the concentration of products increases and the concentration of the reactant decreases. When the reverse reaction is favorable, the concentration of products decreases and the concentration of the reactant increases. The forward reaction is exothermic, where heat is released, and in the reverse reaction is endothermic, where heat is absorbed. When the pressure is increased, the reaction produces lower gas molecules. And when the pressure is decreased, the reaction produces more gas molecules. Catalysts used in the Haber-Bosch process. So this will go over, what type of catalysts are used during this process to create that ammonia. The main one or the commonly used catalyst is iron. Others that can be used include ruthenium, osmium, uranium, and cobalt molybdenum. Iron is the most used because of how cheap, tough, and has been used in the industry for decades. Over a century ago, a potassium-built iron catalyst was developed. The environmental impacts of the Haber-Bosch process. The cons of the Haber-Bosch process on the environment. So we already know the pros, which is it being used as a fertilizer to help grow food for the environment and for people. But the negative is that the environmental impact of the Haber process is that soil fertilizers are water soluble and can be easily transported in the soil into runoff waters. When it reaches large bodies of water, it can create a phenomenon called eutrophication, which is the unnatural growth of algae on the surface, preventing sunlight from reaching submerged species. The Haber-Bosch process is also the most energy-intensive commodity, responsible for 1 to 2% of global energy consumption and 1.44% of CO2 emissions. Sustainable electrochemical methods. We are pushing forward to a carbon-free society with growing renewable energy for our increasing energy demands. Ammonia offers a unique opportunity since it is high in hydrogen content to create long-term energy storage and transportation. This can be achieved by combining ammonia with other renewable energy sources. If the Haber process were to be redefined and modified, it can create cleaner, renewable energy. There has been research on finding new chemical, physical, and electrical catalysts that are long lived. Another way scientists have tried to make the Haber process more sustainable is using electrochemical synthesis of ammonia, using water as a proton source, and electric energy to drive the ammonia synthesis reaction will decrease not only the fossil fuel consumption but the CO2 emissions as well. There have been great reports of electrocatalysts for ammonia being used that have been highly favorable. So thank you so much for listening to my presentation, and I hope that this is approved. Thank you so much.